may be wondering, how do I implement pull? Implementing pull systems can be complicated. Fortunately, we can follow 6 basic steps that will help us stay on track and get pull set up. So what are those steps? Pull it. Pull it is a simple way to remember the 6 steps that we'll cover in the next few modules. Pull it stands for number 1, prepare to make changes. Number 2, understand the current process. Number 3, lay out equipment in sequence. Number 4, lock in cellular manufacturing. Then implement Kanban, and finally transition to single piece flow. These 6 steps will help you get started with a pull system. With this in mind, we'll see you in the next module where we can begin to pull it. Much like any other implementation, the first step to implementing pull is to prepare to make changes. Before implementing pull, you will first need to answer the question, where do I want to implement pull? What process? And what area or what value stream will I implement in? Once you've decided where to implement your pull system, you'll need to assemble a team. Be sure when you do that you include people from the Gemba who work on the front lines every day. These individuals will have a great deal of experience and expertise in the area you are implementing. After your team is organized, you'll want to go for a Gemba walk. Observe the area, take photos, videos, and lots of notes, as they will be helpful for you later on. Once you've done this, take a little time to reflect on your Gemba walk with your team and update notes, compare thoughts, and get ready to implement pull. In most organizations, a functional layout is established. Functional layouts are by far the most common layout you will find in organizations. These layouts can be seen in how machines and people are positioned. A functional layout is a workspace configuration in which operations and processes are organized by the type of work or function that they do. In these functional layouts, people are trained to perform work on one machine and one machine only. As you can see in the example, drill presses are all together. Assembly is together. Inventory and milling machines are all placed together. While these functional layouts may be easy to set up, they take no regard for the sequence of operations. In other words, the process to manufacture an item is a bit chaotic. In this circumstance, you need to first understand the current process or flow of production. In the example, you see a layout of the plant is drawn and arrows guide the flow of production. Numbers are used to identify the answers to the following questions. Where does the process begin? And where does the process end? This is a very simplified way that you can establish a very basic spaghetti diagram. Now let's stretch your mind a bit. In the upcoming assignment or comments section of this module, it's your turn to choose a production process in your place of work. Once you've selected a process, then you can answer the following questions. First, what is the total distance that someone would have to travel in between operations through the entire process? You can find this by walking the flow of the process. Next, how much is the total time of that distance traveled? And finally, what is the total time of the entire process? We look forward to reading your answers, and we'll see you in the next module. In the pullet stages, phase 2 is to co-locate the equipment according to the process sequence. This is where you move equipment into a sequential layout according to the flow of your production process. One challenge that you may run into is moving what are known as large monuments. Monuments are large, difficult, and specialized machinery that is tough to reorganize. If you run into this situation, you'll want to move the smaller pieces of equipment around the monuments according to the process flow. This will allow you to avoid the struggle of hiring and moving these machines and take full advantage of the machines for processes that may use batch manufacturing. In these cases, you can build cells around the monuments. Once you have moved your functional layout into a process-based layout, you will have a great reduction in the distance traveled as well as the production times. One other benefit of co-locating your equipment in a sequence is that it makes it much easier to see work in process inventory build up, which will help you remove inventory waste later on. Now, before we go, we'd like to give you a few questions that you can answer in the comments section or the upcoming assignments section of this module. Firstly, do you have any large monuments or machines that are part of a process that you cannot move? And then, can you move equipment anywhere you want, or would you need to plan a Kaizen event to change your layouts from a functional layout to a process-based layout? Remember, these questions are meant to get you thinking about actionable items as well as give you feedback. We look forward to hearing from you, and we'll see you in the next module. After all your equipment has been co-located and placed in the order of your production flow, you can now maximize the benefits of your co-location by placing your equipment into a cell. Cellular layouts are the optimal flow-based layout. A cell is a close arrangement or setup of people, machines, or workstations. The purpose of a cellular layout is to fulfill a processing sequence while simultaneously reducing wait times, transportation, and other forms of muda. Cells can be difficult to set up and may require you to schedule a Kaizen event to make the adjustments. This is why you should co-locate the equipment according to sequence before designing a cell. In some cases, however, an office, for example, may not need to co-locate items because you mainly move computers, desks, and other lighter items, whereas a shop floor that has monuments would need to be co-located before building your cell. Keep in mind, there are many different types of cells that can be built. With this in mind, in the next 3 modules, we will discuss 3 important aspects of your designing of cells. Those are sequence, cell shapes, and point of use placement. We'll see you in the next module. Organizing equipment and information according to work sequence places things in order, and not only will it reduce forms of waste in your cells, it will also expose other forms of waste too. For example, when you place your equipment in a sequential order, work in process inventory cannot be stacked up in extreme amounts, which means that over time your inventory level should go down. In addition to this benefit, you will greatly reduce transportation distances in comparison to a functional layout. With this in mind, it will also expose many opportunities for you. For example, if a machine breaks down, you will know right away. When a machine goes idle, you will see the issue right away, and you can get it fixed as soon as possible. Another opportunity that will become obvious when equipment is co-located and placed in sequence is that you will need to balance the work that is performed on the line. This is referred to as line balancing. As you can tell, the benefits of moving from a functional-based layout far exceed any challenges that you might be presented with. Lead times will go down, floor space will be freed up, and WIP inventory will be reduced, which ultimately frees up cash flow for your organization. There is one more benefit that we feel we should mention too, and that is the benefit that directly relates to people. When operators work in cells, they gain first-hand experience of detail within the cell and the entire process. Oftentimes they see small details that add up to great opportunities to improve and make work easier. As operators identify forms of waste and issues within the cell they are working in, they can share ideas and brainstorm how they can improve their lines. You will see that after your cells are established, operators who work in the cells will develop a great sense of pride for their cell. And that's it, the basics of work sequence. A work cell is commonly thought of as a U-shaped or C-shaped cell. Truthfully speaking, though, they can be designed in a variety of ways to fit your specific needs. One important thing to remember is that the cells should not be designed in a mini-functional layout. They need to be organized by the flow of your process. This will ensure that the cell is process-based and not operational-based. While there are many different shapes, cells are most commonly organized in straight line, I-shaped layouts, L-shaped layouts, U-shaped layouts, C-shaped layouts, and sometimes even S-shaped layouts. Some things to keep in mind when designing your cells are: what size are your equipment? What is the shape of the equipment? Is the item in constant production or not? And is the material used on the cell difficult to move? Cells should be able to flow freely upstream and downstream, and workers should be trained on the entire cell. While cells may require a Kaizen event to set up, they will also yield some massive advantages. Some of those advantages include walking distance and transportation muda are reduced, work in process is reduced, the communication of people increases, line balancing of the cell, and the entire value stream becomes much easier, and lead times drastically go down. Keep these benefits in mind as you build your cells, and we'll see you in the next lecture. One of the purposes of a cell is that the process flow is all set close together. This reduces transportation and motion waste within the cell. This close together placement is referred to as point of use placement. Each of the operations within the cell should be placed as close together as possible, so that all forms of muda are minimized and the cell is already in a position to transform from Kanban to one-piece flow. As you begin to establish your cell design, you will see that lead times will be drastically reduced, as well as forms of motion like reaching, bending, lifting, stretching, twisting, and other dangerous movements. This reassures that the cell is not only a superior design compared to its functional counterpart, and that it is safer as well. One activity that can really help maximize your point of use design is 5S. The 5S system should be in place to save space, keep things organized, and reveal waste as well as opportunities to improve. One last thing before we move on. As you place your operations in a process flow layout within a cell, be sure that all needed supplies, materials, tools, and equipment are within the operator's reach. They should also follow the production flow of the materials or information so that they can flow in and out very smoothly. And that's it. Point of use placement within a cell. At this point in your pull system implementation, it's time to begin implementing a Kanban system. Remember, the ultimate place to be in true pull is one-piece flow. But Kanban will help you begin to get there. Kanban will be one of the most important phases of your transition to true pull. And where one-piece flow is not yet possible, you can use Kanban. The system will act as a control and a guide for the flow of materials and information. Kanbans will act like a production order for each of the materials or information that may be needed. Remember that the information in a pull system flows upstream as it is pulled from the sales team to the production or procurement team. In a push system, the information is pushed downstream. Let's review the basic flow of the system. Keep in mind that a Kanban will follow the flow and will provide direction on what and how much point of production. Here's an example. First, your customer orders a product. Then, a work order is created and sent to the appropriate assembly point. After this, the assembly then sends a request to the appropriate points of manufacturing. The manufacturing point then orders materials that might be needed. As you can see in this very basic example, the flow moves from downstream to upstream, and while there will likely be more details in your flow that will need to be defined, this example shows how Kanban works. This is the opposite of a push system. Remember that your implementation of the Kanban system will likely be most effective internally, closest to the customer, and moving upstream. Kanban can take time to implement, as it is a culture change, but the benefits are well worth it. Keep in mind that if you are using an MRP or ERP system, there are some techniques that you can use so that these valuable systems are not phased out immediately. What you are trying to do is lower inventory to absolutely only what is necessary. And when switching from systems like ERP or MRP, this may require techniques like supermarkets in between your process steps. It may also help for users to become educated and have a basic understanding of ERP and MRP so that they can phase it out appropriately. We'll discuss more about Kanban in the coming modules. See you in the next lecture. In the last phase of the pull it methodology, you will transition to one-piece or single-piece flow. An environment that operates in a one-piece flow fashion is when items or services are processed in one piece at a time manner. Each piece is also produced based on a given rate that is determined by the customer. Some of your processes may have foreseen this transition from Kanban to one-piece flow and already started producing in this fashion. That's great if they did. Others, however, may need a little bit of transitioning to a one-piece flow production. This may include types of encouragement for them to understand one-piece flow. We will look more at the details surrounding one-piece flow in later modules, but for now, let's understand some of the key benefits of switching to this method. The first is that it will expose many forms of waste. You will also find that transportation is much more functional and warehousing needs will be dramatically reduced. Another great benefit of one-piece flow is that lead times will be reduced, and that means customers spend less time waiting for deliveries. Finally, risk is decreased substantially in an environment where one-piece flow is implemented. Damage goes down, obsolescence is reduced, and deterioration is minimized. As you can tell, implementing one-piece flow can be a valuable tactic for a company and is a necessary part of implementing any pull system. We'll see you in the next module. Over the last few modules, we've discussed why companies choose to use batch production and some of the problems that are associated with large lot production. We've also discussed the benefits of lowering lot sizes and how this can assist organizations to level their production. We must keep in mind that smaller lot sizes can only be implemented in combination with lowering changeover and setup times from hours to minutes. This is done using systems like SMED or the reduce methodology. Now we are going to dive into transformation of level loading and its role in small lot production. So, let's dive in. Level loading is also known as load smoothing and heijunka in the world of lean manufacturing. Whichever term you refer to it as, level loading is basically a term used to define a method of scheduling your daily production of different types of products. It works by smoothing out the peaks and valleys that so often occur when varying products and product families are produced together. Essentially, your orders are placed in a sequence that creates a repetitive pattern and smooths out the day-to-day variations in the total orders. This helps to smooth out the demand over a longer period of time as well. In the example shown here, you can see how the monthly output is converted to the daily output, and then a leveled production schedule is created. Now that you know what a leveled production is, we're going to look at 3 critical pieces of load leveling formula. Those are shish kebab production, tack time, and the load leveling box, also known as the heijunka box. We'll see you in the next module. In traditional organizations, a business will calculate the required product or information for each month and produce it all at once. This is known as mass production. For example, a company with products X, Y, and Z would calculate the total amount of each product for the month and then would produce all of product X before moving on to production of product Y and then Z. This type of production scheduling is frequently referred to as shish kebab production because much like your favorite shish kebab, each product is produced or eaten in chunks. There are 3 different types of shish kebab production. Mass production, this is where all of one product is produced before moving on to the next. Then the next type is segmented production. This is further divided into daily needs or batches, and finally, mixed modal production. This production method is the practice of making, assembling, or producing several different parts or products in varying lot sizes so that the organization produces close to the same mix of products or services that will be sold on the same day. When you are leveling production, the customer ultimately determines and drives everything. This means that the final process in your sequence determines how many of each of your products is made to match customer demand. In addition to this, that demand is mixed evenly so as to ensure the proper production amounts are performed daily using mixed modal production. This ensures that the quantities that are produced are smooth, level, and in proper repetitive sequence. In later modules, we'll also discuss the rate at which products need to be produced to keep things level. Remember, leveling is fundamental to both just-in-time production and pull systems. We'll see you in the next module. When trying to level a production schedule, one of the critical pieces of your daily schedule is takt time. Takt time is a calculation that helps you match your schedule to that of the customer demand. Defined, it refers to the rate at which products, information, and/or services need to be completed in to keep up with customer demand. The formula for calculating takt time is shown here. Let's look at a basic example. First, we need to calculate the time available in a shift. Let's assume we have 8 hours in a day available. This means that we have 480 minutes per day of available work time. Now we need to calculate the customer demand per day. To do this, let's assume that we need to produce 17,500 units per month, and we have 20 available days per month. This means that we need to produce 875 units per day to keep up with customer demand. Now we can calculate the takt time. To do this, we divide our 480 minutes of available work time by our 875 units of demand, and we get a takt time of 0.55 minutes. These are the minutes we need to produce. In other words, 1 unit every 0.55 minutes to keep up with customer demand. Now with our takt time, we can keep a steady pace of production according to the market needs. And if the market is up, our takt time will be faster. If the market is down, our takt time will be slower. Being aware and producing at a takt time will drastically help you in leveling production. Keep in mind that quick changeovers are an absolute necessity and a prerequisite to actually reaching a level schedule. We'll see you in the next module. Once you have a takt time established, you need to ensure that keeping up with that time is possible. One of the best methods to visually manage your orders and keep track of when your orders need to start is by using a load leveling box. The load leveling box is also known as a Heijunka box and helps you visually communicate to workers when an order needs to be produced. The Heijunka box typically lists products down the left-hand side and time intervals across the top. Kanban cards, routers, or another trigger are then placed in the appropriate box and time for workers to act on. This helps workers to visually manage what needs to be done and when. And that's it, a load leveling box. that will help you level your production floor. We'll see you in the next module. If you're going to implement pull in your organization, you need to ensure that all of your lines are balanced. Line balancing is the leveling of your workload across all processes to remove bottlenecks, excess capacity, and ensure that the work is evenly spread across all workers to meet your takt time. As we've learned in other modules, the customer determines the demand, and ultimately those customers create the market. As such, the market will determine the different types of products and their appropriate amounts that will need to be manufactured or produced. One thing to be cautious of, it's the ever-changing market demand. When the market changes, you will need to make the appropriate adjustments to keep your lines in balance and maintain the correct takt time. Please be sure to remember two very basic techniques when balancing your lines. When demand increases, you will need to adjust more resources into the line to support the needs. Likewise, when demand decreases, your resources can be shifted to other areas of the organization. Charts like the one shown in this module can be used to help you balance your lines. Percent charts allow you to see and make appropriate adjustments when needed. Other techniques like cross-training, the appropriate quality systems, and appropriate management will be discussed in other modules. The only way that a pull system can balance lines and meet market demands is with a healthy cross-training program. Markets will go up and down, and the ability to move your resources around is one of the most important things that you can develop. This means that employees must be given opportunities to train and function throughout the entire organization. Many companies will use training programs and training matrices to track employees' skills. When an employee is given opportunities to cross-train, it strengthens a company, enhances the employee's confidence, and allows them to teach others when their skills have been developed. There is no doubt that cross-training is an absolute necessity in the implementation of a pull system. We'll see you in the next module. Like any other organization, quality in a pull system is critical so that flow occurs smoothly in a pull system. Each person is responsible for ensuring that quality occurs in their tasks. Most organizations that implement pull will use many of the principles from a lean organization or the ZQC system that was created by Shigeo Shingo. Both of these quality systems are often used with a clear understanding of the 5 levels of quality. The first is independent inspections. The second is when people inspect products or information as it is produced. The third is when a downstream person checks a product or information as they are received. The fourth level of inspection is mistake proofing or poka-yoke of errors and standardization. The last level of quality is when both internal and external suppliers control their processes and never pass on errors or defects. As you may have guessed, operator inspection of products and information and downstream checks are the 2 fundamental levels of quality in a pull system. These levels, however, must follow the most basic knowledge and rules if you want to succeed. Never allow a defective product to enter your workstation. Never produce a defective product. Never allow a defective product to move out of your area. These 3 rules will help ensure that your pull system can flow freely and that any defects will reveal new opportunities to improve. We'll see you in the next module. Have you ever wondered, what's the difference between an error and a defect? An error typically occurs before a defect and oftentimes is unknown until it results in a defect. A defect, on the other hand, is any output from a service or a product that does not meet the customer required specifications, standards, or requirements. Daily huddles, Kaizen, and even improvement meetings should be focused on discussing ways to eliminate waste and remove errors and defects in daily operations. 2 very important pieces to eliminate defects are finding and removing root cause through analysis and implementing systems like Poka-Yoke, which is part of the ZQC system created by Dr. Shigeo Shingo. It is important to note that when seeking to eliminate errors and reduce defects, you will need to find a way to distinguish between the error and the defect, especially as it pertains to causation. 2 very simple techniques that can be combined to make this process easier are the fishbone diagram and the 5 whys. This way you can discover the errors and drill into possible root causes. Once this is complete, your team can then brainstorm opportunities to improve. Now you know the difference between an error and a defect, and you understand a basic process for drilling into errors. We'll see you in the next module.